Hello. So I figured as long as time permits that I would take some videos today to show everyone what I do for work. I'm going to be, of course, not sharing lots of information to make sure that the client and my job is respected, but everything that I can share, I will. So I'm out here on a site. We do a safety checklist when we first show up to a site. Now I'm opening all the wells. I've gotten most of them opened already, but I figured I'd show you the last one that I had to do. This is something that we have to do every time that we show up to a site. Helps us inventory all the wells, make sure they're all accounted for. So here's a well, very typical groundwater monitoring well, and I have to open it. So I will use my ratchet here, clear off some of these rocks. Sometimes they're pretty good, sometimes these old nuts break. Just depends. Pull out, this is called a J plug. And there we go. That allows the gases in the well to vent, and it is definitely important that we do that before we gauge. So that's the first part of my job, all taken care of. That usually takes about 10 to 20 minutes. Alrighty, so this is the next phase of my job. I have to gauge a well. This is extremely important in understanding the hydrogeology of the site. So this is a IP. This is the device that we use that detects water, has a little probe on the end of it, and then this part is a tape measure. So it can detect when there's both product and water in the well. It'll beep at me. Since we deal with contaminated wells all the time, this is a decontamination bucket. It has chemicals in it that will neutralize all of the contaminated all the chemicals that could get on the IP. Since we're a remediation company in groundwater monitoring, the last thing we want to do is stick this down a dirty well, bring it over to a clean well, and introduce contamination into that well. That would be very, very bad. So that is another big part of it. So there's also plenty of paperwork to do in science, as always. So let's get started here. Normally we have two people. One person will do the iPad and the paperwork, but since I'm on a solo site today, it's all up to me to do everything. Yeah, I'll lower the gauge down. I'll listen to when it starts and stops beeping, and then I'll read the tape measure at the top of the casing. Looks like 4.60 inches. And 1317. All right. So now we have a special procedure. So fancy, so high tech. Get a little of the chemical on the tape, on a paper towel, and so that we can clean the tape. We reel this up. We also check for soft bottom if this has sediment on it. We need to clear declare the well that has a soft bottom. That changes the math and calculations sometimes to the bottom of the well. Chemicals. I know that this is a clean well, so I'm not too worried about it. It is important to be very thorough. The last thing we want to do is get contamination anywhere where it's not supposed to be. And that's it. That's a well gauged. This is by far one of the biggest chunks that we have to do. So I have 11 more to do. Another huge aspect of my job is paperwork. Clearly, if you're doing any sort of scientific endeavor or data gathering endeavor, record keeping, bookkeeping is incredibly important, and it takes up a huge portion of my day. So right now, I'm entering in all of the depth to water and depth to the bottom of the wells in my iPad here. That way it'll keep track of it, makes it easier for report making later in the day, and it'll actually do all of the calculations for my purge volumes, which is super nice. So, yeah. This is definitely tedious, but well worth the effort. All right, so this is the basic setup for sampling. Everybody's gonna do it different, but this is how we do it at Tasman. Sampling essentially involves taking one of these plastic balers, putting it down a well, taking a certain amount of water out, and then sampling. The rest of this is just for record keeping and to make sure we label everything correctly. So here we have our BOAs. This is the containers that we put our samples into. Over here we have our paperwork, our map, and our labels, which I won't show to keep information private. This is twine that we use, gloves for every, new pair of gloves for every single well, Ziploc baggies to keep 3 containers of BOAs. That's what we have to do for most of our monitoring wells. And then of course, you know, science produces a lot of trash, so we have to have our trash bag. So I'll go ahead and run through the process of doing one sort of one whole well from start to finish, and then I'll do the rest. All right, so the first thing we do is we choose which well we want to go to. It's arbitrary. Sometimes when you're working with the team, try and divvy it up. I'm just going to start at a place that I know the location of, and that's BH05. And I'm going to write my labels down here. So this site in particular, we are sampling both for organic and inorganic compounds. So this is a 250 milliliter poly. That will be for our inorganic samples. Very important on groundwater sampling days is to have a sampling pouch. BOAs. These are for our organic compounds. BOAs, when you fill them up, You want to make sure that there's no headspace, as the chemicals often that we look for can off gas or volatilize, and that will change the amount that's in the water, which will not be representative of what's in the ground. So making sure that there's no air in these is crucial. Once you have your containers, you can go ahead and get your baler ready. Just gonna do a little bookkeeping there just so I can keep track of wells that I've been to. So we are super high tech here on groundwater sampling. Take your twine. The last thing you want to do is do not want to lose a baler down a well. So attaching it to your finger, the twine, is very, very important to remember. So now I look at how far down the well is. In this case, it's approximately 15 feet. So I want to make sure I do enough twists around my hand to get that. All right, that should be good. I'm gonna come over here, grab myself a baler. You see it's in plastic. Very typical of science to have everything single-use plastic, no contamination whatsoever. This is a pretty low-tech, high-tech piece of equipment. It's essentially just a bucket and has a ball valve down here so that the water can enter through the bottom, but that when you pull up, it closes this ball valve so that the water doesn't fall out. That makes it really easy to retrieve water out of a well that's about the same diameter, a little bit larger than this baler. So now I'm just gonna attach my baler to my twine. Pardon my sniffly nose today, it's a bit chilly out here. I tend to tie a lot of knots. Every person's a little bit different. I just really don't want to lose a baler down a well. And we're good to go. We have our notes taken, we know where we're going, we have all of our sampling containers, we have our baler. The last thing we need is a purge bucket, and I will show you guys that over at the well. All right, so we're out here at the well. Really, really simple. There's a certain amount of water that is in the well, right? So if we imagine this baler is the well, and the water's from here to the bottom, that water's been sitting there for 3 months, 4 months. So that's not very representative of the groundwater that's around the well. So what we need to do is purge. It's a very common thing. So I need to remove the amount of water that is in the well and a little bit around before I sample. So that's what this bucket's for. Typically the water we purge is contaminated, so we dispose of this in proper disposal containers according to the client, according to the project. So for this particular well, I need to do about 0.6 gallons, which is about 12 pulls from this baler. Because one of these balers is 0.05 gallons. So it's pretty simple. We stick our baler in the hole there. Let it go down to grab some water. Super high tech. Pull the bucket up from the well, and we have a baler full of water, which we do that about 12 more times, and you will have successfully groundwater sampled. So I may try and do a time lapse of me doing the entire site. We'll see. All right, so I figured I'd check in. I've completed purging this well, and now I'm about to sample. Nothing high-tech about it. There are some things you want to think about, at least that I have to think about. So at my company, we always sample organics first, because those are the ones that we really do care about the most. So I have my VOA here. It is now open, and I just pour from the baler into the VOA. I fill up the lid as well. And now I check for an air bubble. Remember, I was talking about those volatile organic compounds off-gassing. Making sure we don't have a bubble is very important. Typically, these 1-inch balers will have enough water for 3 VOAs. Now, oftentimes, you will have to deal with wells that go dry, that there's not enough water. Sometimes you will have to wait. Sometimes you'll only pull a baler out with that much water in it. So you have to pull a bunch of times in order to get all of your necessary sample water. Other times wells go completely dry, and then you'll have to come back, wait about 30 minutes to an hour, hopefully let the well recharge. Sometimes that's not always the case, and then you were just unable to sample. These are kind of things that you rely on previous experiences with, from past field notes, other coworkers that have been to the site, and also just developing a gut intuition about, oh man, I'm running out of water in my baler, maybe it's time to sample. So now I'm filling up the inorganic poly. Oftentimes this one can be the most challenging to get enough water for, especially if your well is going dry. One thing that I had to figure out is, how do I keep a poly open while retrieving a baler? Not very graceful, but it works. So we fill up the rest of the poly here. Put that in our pocket. Put the rest in our purge bucket. Just makes it easier so our twine doesn't get caught on anything on the way back to the truck. We're done with this well, so we can also close it up. Put the J plug back in. These wells this well didn't have any screws, but just put the lid back on. And yeah, that's it. So that's essentially how you sample a well with a baler. And yeah. All right, so it is 1:30. I got out to the site at about 9:40, so 3.5 to 4 hours. I did 12 wells today. I just finished up. Not bad at all. I hope that this video has given you at least a taste of what it's like for me every single day. There's a lot more that goes into it, a lot of details that I left out. But in thinking about being brief and not wanting to bore you guys with minutiae and details of my job, I figured that that was a pretty good overview of what I do. I hope that you enjoyed this video, and please, if you have any questions, feel free to reach out to me. I'd love to answer any of them. And thanks for watching.